Alright, welcome to problem number 1 from problem set 1. So he says, read the following code and write comments on each line explaining what's going on. Alright, so here's how comments work. Anything after this pound sign is not regarded as code, so it's just for the reader. So this will assign A1 the value of what is ever on the right side of this equation, formula, whatever you want to call it, and run if we can go down here, find out what run if does. It creates a uniform distribution, and its argument is how many numbers that you want. So it assigns A1 the value of 100 random numbers from a uniform distribution. So now when we run this code, it still works. If we didn't have that hash, that pound sign there, it'd freak out. Okay, so what does this do? Same thing. Assigns A2 to be a list of the same thing of 100 random numbers from a normal distribution. And if we run that line, and then why don't we even just check to make sure? Yep, that's what it does. That's what it does. It looks like it's from a range. Well, it's a normal distribution, so it really could have an infinite range. And then what does this do? A3 equals A1 times A2. Assigns A3 to be the value of A1 times, well, that's kind of cheating to say. A1 times A2, well, kind of duh. So what does A3 actually look like, though? So it multiplies pairwise the list by each other. So assigns A3 to the value of A1. Yeah, sure, that works. Alright, so what is this? What does cbind do? Well, question mark, cbind. Combine objects by row or columns. So if we run it, and then I look at it, a tab, it looks like it just combines those lists as columns right here. So let's say with that, combines lists A1, A2, and A3 as columns in a data set. I'm not exactly sure if this is a matrix or data set. Alright, oops. We'll copy and paste there. Alright, so what does this do? Pairs. It looks like it scatter plots every possible combination. So A1 by A2 is that guy, A1 by A3 is that guy, A1 by A2 is that guy, A2 by A3 is that guy, you get it. Plots all combinations of variables from the A-tab data set. Alright, so what does that do? Look, it gives us a table of correlations. So obviously A1 times A1, they don't even bother plotting it because of course it's a perfect correlation. It's the same exact numbers. And that's why this diagonal, the same with here, the diagonal is always going to be a correlation of 1 or just not interesting enough to even look at. Correlation table for each combo of variables. Okay. Alright, so what does this do? That's pretty simple. So sets A to be 100. And then what does this do? B is to A. So now what is B? B is whatever A was, so 100. Sets B to be A, which in reality is 100. And then what does this do? A. So now if we look at A, now it's 200. sets A to be 200 instead of 100. So now we lost whatever A was before because we overwrote it. But what happens to B? It's still 100 because we didn't tell B to do anything else. So that's pretty important to know. So that sets A to be 200 instead of 100, but does nothing to B. So if we were to rerun this now that A is already 200, and now B shall be defined as A, then when we look at what B is, it's 200 now. But before, if we go back, boom, back to 100. All right. And let's see, what does this do? A is a list of 1, 2, 3, 4, 5. Creates a, he called that a vector of 1 through 5, or a list. I'm not very consistent in my commenting. Once you get like actual messy looking code, it's kind of worth the time to go in and, you know, be really consistent with how you do everything. Because once you come back in the next day, you're like, what does this even do? Okay. Alright, creates a vector, so what does this do? Same thing as before. B sets B to be A, basically. Now, what does this do? We look at it. 1, 2, 10. So this is an index, so we know that B is a list or a vector, and it's saying the third item in that list will now be defined as 10, or make the third thing in that list equal to 10. Third item in that list to be 10. Yep, and if we look at A, same thing, it still doesn't change. Same thing as the previous exercise. Alright, that should be number 1. Alright.